Find the period, any asymptotes, and sketch two periods of f of x equals 6 cosecant of pi over 3x plus pi. This is the graph of cosecant. The number 6 is the vertical stretch, and so we would make the graph longer vertically. The number pi over 3 is the horizontal shrinking because pi is approximately 3.14, and so pi over 3 is less than 1. And so if this number is less than 1, and if it is a horizontal transformation, in this case, it shrinks the graph horizontally by a factor of 3 over pi. And then the plus pi will tell us that this graph shifts the graph of cosecant to the left, but not pi units. To determine how many units this graph shifted the graph of cosecant to the left, we would need to factor out pi over 3 inside of cosecant. If we have pi over 3x and we factor out pi over 3, then we have x. Similarly, if we have pi and we factor out pi over 3, then we have 3 left inside. And so we can double check to make sure that this is the original expression. Pi over 3 times x is pi over 3x. Pi over 3 times 3 is pi. And so we know that this graph shifted the graph of cosecant of x to the left 3 units. But this is not quite 3 units because of the horizontal shrinking as well. Regardless, we will need to find the vertical asymptote. The original graph of cotangent lies between 0 and 2 pi, with the exception that it is not defined at pi. And so this time pi over 3 times x plus 3 varies between 0 and 2 pi. Remember that there is another vertical asymptote in the middle, but we will find the endpoints first. To isolate x, we first multiply all parts with 3 over pi, which is the reciprocal of pi over 3. 0 times 3 over pi is 0. The middle part is now x plus 3 because pi over 3 times 3 over pi cancelled out. And 2 pi times 3 over pi is now 6. We then isolate x to get 0 minus 3, which is negative 3, less than x less than 6 minus 3 is 3. The period of this function is 6 because 3 minus negative 3 is 6. Alternatively, we know that the period of cosecant is 2 pi. We simply take 2 pi divided by the constant multiple in front of x inside of the cosecant function, which is pi over 3. 2 pi divided by pi over 3 is 2 pi times 3 over pi, which is 6. Regardless, the length of one complete period is 6. Thus, one complete cycle of this function lies between negative 3 and 3. Remember, there is another vertical asymptote between these two. And so, we set up the Cartesian coordinate system with the vertical asymptote at negative 3. This is x equals negative 3 at x equals 0. This is the vertical asymptote between the endpoints. And one more vertical asymptote at x equals 3. The number 6 in the equation is simply a vertical stretch, and so we will put in the graph first, and we will label the graph accordingly. the graph of cosecant of x would concave up in the first interval and then concave down in the second interval, but with the equidistant. Now, when x equals -3/2, the y value should be +6. And when x equals +3/2, which is half the distance from 0 to 3, the y value should be -6. Essentially, this is the graph of cosecant of x, but with different labeling and with the horizontal shifting, so that we now have the corresponding vertical asymptotes in the appropriate place. We're asked to graph two periods. This is only one period, and so we would either go to the left or to the right, or we would add half of the period on the right and half of the period on the left. Going from x equals 3 to x equals 6 would give us half of the period, because half of the period go from 0 to 3. Going from -6 to x equals -3 would give us half of the period as well. Using symmetry, we simply copy the graph of cosecant in these appropriate intervals. Note that if we were to plug in 3/2 into the given function, we would have 6 cosecant of pi/3 times 3/2 plus pi. This is 6 cosecant of pi/2 plus pi, which is 6 cosecant of 3 pi/2, or 6 over sine of 3 pi/2. But we know the sine of 3 pi/2 is -1, so this is 6 over -1, or -6. And that is how we get -6